Okay, continuing with problem 4, we're dividing radical expressions. What is the simplest form of this quotient? And for the first problem that we have, it is the square root of 18x to the 5th divided by the square root of 2x cubed. So the first thing we want to do is combine this under one big radical sign. So we have 18x to the 5th over 2x cubed, and we can separate this if you'd like, and we know that's going to be 18 over 2 times x to the 5th over x cubed. 18 divided by 2 is 9, and that becomes x to the 5 minus 3, which is x squared. So now we can rewrite that as square root of 3 squared times x squared. So now that they're all squared, we can cancel that out, and it becomes equal to 3x, and that's our answer. Our next problem, we have the cubed root of 162 y to the 5th over the cubed root of 3y squared. So the first thing we want to do again is combine it under one radical sign, and then process them. So 162 divided by 3 is 54, and y to the 5th over y squared is y to the 5 minus 2, which is y cubed. So now that puts us here. Now we want to write things in a cube factors if we can. So we know 54 has a cubed root factor, which is 27. And 27 is 3 cubed. So we're going to use that. So it's 54 is 27 times 2. So there it is, 27 times 2. And they've just left out this step here, if you're wondering how they got from there to there. So they left out this 27 times 2 times y cubed. All right. So now they just split it up, 27 y cubed in the first radical, and then the cubed root there. Okay, so now we can rewrite this as 3 cubed y cubed. So the cubic root of 3 cubed y cubed, and then this is just a straight copy down, cube root of 2. So now this becomes 3y and times the cube root of 2. So that's our answer, 3y times the cubed root of 2. Here's our got it. So you can pause if you want extra practice. So another way to simplify a radical expression is to rationalize the denominator. Remember when we used to clear square roots out of the denominator? We're still going to do that, but with more than squares. So we've got to make that denominator something we can work with. So we rewrite expression so that there's no radicals in any denominator and no denominator in any radical. Okay, so that's the rule. So when we have a radical in the denominator here, we've got to clear it. So remember back in Algebra 1, what do? We would multiply it by 1, but we would make 1 fit our needs. We need to clear that radical, so we'll make 1 square root of 2 over square root of 2. So we haven't changed this fraction, we've just changed the way it looks, but to fit our needs, because we want to clear that radical. So when we multiply that denominator, radical 2, or square root of 2 times square root of 2, we just get 2. So now we've multiplied this fraction by 1, and our 1 is square root of 2 over square root of 2, and we cleared the denominator to get 2. So it's a straight multiply on this, so 1 times the square root of 2 is square root of 2, and on the bottom, square root of 2 times square root of 2 is just 2. So this is called rationalizing the denominator. We cleared it to a real number. So we're going to use that in our last problem of the day, rationalizing the denominator. What is the simplest form of the cubed root of 5x squared over, or divided by, 12y squared z? So the first thing we want to do is split it up. And so before we were putting it all together. Now we have to split it up so we can work with it independently. So we're going to take it from this, the cubed root of that whole fraction, and then we're just going to put the cube root over the denominator, or numerator, and the denominator. Okay, now we've got to clear this crazy denominator there. All right, so how do we choose what to multiply it by? So we need to choose a cube root with a radicand that will make each factor of the radicand in the denominator a perfect cube. So we've got to try to make everything there a perfect cube so we can clear the denominator. So what do we need? So the radicand in the denominator, we need a 2, 3 squared, y, and a z squared to make these factors here perfect cubes. Because see, if we multiply the 2 squared by one more 2, we'll have 2 cubed. If we multiply this 3 by 3 squared, we'll have 3 cubed. If we multiply y squared times y, then we have y cubed. And if we multiply the z times z squared, we'll have z cubed. So that's what we're going to use to get our denominator and to rationalize our denominator. So we're going to multiply by the cubed root of these things to turn everything in that denominator to a cube. And if we do it to the denominator, we have to do it to the numerator, because what are we doing here? We're just multiplying this by 1. Okay? So when we do this, it cubes everything on the bottom, and then you just combine and do the math on the top. So we have 3 squared, which is 36 times 2 times 5 over here. That gives us 90. And then we have an x squared, y, z squared. And there that all is. So you just do the straight multiplication. And then on the bottom, notice now everything is cubed. 2 cubed, 3 cubed, y cubed, z cubed. That was our goal from the very beginning, because we have to clear this out because our index was 3. If our index had been 5 for all this, we would have made everything a 5th power. But because we're trying to clear the cube in our index, we make everything a 3, power of 3. So now that we did that, now we can finally get rid of that radical sign in our cube roots, and we end up with 2, 3yz. 2 times 3yz. Okay, and then the top is going to stay the same, the numerator. And that 2 times 3yz becomes 6yz, and we are done. That's as far as we can take it. We can't do any more math between the numerator and denominator because they're not like radicals anymore. Okay, the denominator is not even a radical, just the top. So you can't do any more math or simplifying there. It's in its simplest form. So our got it is here. So again, pause and work on this. And that completes our assignment today. And I've asked all the students to work on the workbook 6.2, Practice K, and we're going to work problems. Okay, so we're working problems 2, 3, 4, 5, 7, 8, 10, 11, 15, 16, 19, and 20. Okay, and work on this for the rest of the hour, and it is due tomorrow morning. Thanks for watching, and work hard.